Hello all, welcome to the session of mechanical system design. In today's session, we'll continue with our series of material handling and systems. In last session, we have dealt with related to gear design. Now myself Rohit Bhaskar, Assistant Professor Mechanical Engineering in KK Institute of Engineering Education and Research, Nasik. So we'll start with today's session. So today's session consists of material handling systems. So what exactly material handling consists of, or what type of material handling systems are there, equipments are there, or what we required related to the transportation of materials. So first of all, before understanding all this, we'll first see the process or the steps involved in material handling system. So material handling system usually consists of three steps. So first one is consisting of picking up the load. So whatever is the product or whatever we consist industrial product consist of, so we have to first pick the product from the manufacturing line. Then second step come into picture, that is transporting the load. So the place from where the product is to be picked up is to be transported at a suitable location. So transporting the load, so this will be our second step. And then the last step, we can say that setting the load down. So whenever our products are totally manufactured and finished products, we can say, so are to be placed or packed, so setting down will be our third step. So basic three steps are involved in every type of material handling system. So it may consist of number of processes, we can say, or either maybe any type of handling system when we use. So most probably we have to follow this basic three steps, that is picking up the load, transporting the load, and then setting the load. So we can say that these are the three activities we have to follow always. So any of the solution to the material handling problem usually must satisfy these following conditions. Most probably the solution of material handling problem maybe or should not transfer the problem into the other areas of the product cycle, or either we can say that the solution should not only resolve the immediate problem. So whatever problems are there should not resolve the immediate problems, but also it should take care of problems for a reasonably long period. So suppose the transportation is to be done maybe for significantly for a short period, or either maybe for a long period. So this will be the basic three steps, we can say. So moving further, now what are the types of loads, or what is the type of product which we have to transfer, or we can say we have to transport in our second step, as we have seen. So usually we have basic two types of loads which we have to handle. So first one, we can say that bulk load, and second type is nothing but the unit load. So two types of loads usually we have to handle, that is if it comes under the category of material handling. So two categories we have to handle. First one is the bulk load, and second one will be the unit load. So we'll try to understand what are these two types of loads. So first one is the bulk load. So bulk load usually consists of the large homogeneous particles, or we can say that a lump of material. So suppose what type of homogeneous material we can say, suppose small particles may be related to, suppose example is shown over here, that is coal, or either we can say mineral ores are there, or either sand, stone, clay, cement. So small particles which are clubbed together and we have formed a lump together in a homogeneous fashion, so that all types of products, we can say, will come under the category of bulk loads. Whereas second type we can say as unit loads. So what exactly is unit load? We can say a total single load, that is a single rigid mass which is to be handled or transported. So in a one piece, so one piece product, may we can say that either different machineries are there, maybe related to aviation industry, or either maybe to the special purpose industry. So different types of machines are manufactured over there. Either we can say the containers are there, boxes are there, or many products related to this. So these are all come under the category of unit load. So for understanding material handling, we have to first understand the type of load. So these are the basic two types of loads we can say. So coming to the next point, we have containerization. So this is another topic which is very much important to understand, because when load or material come into picture, so we have to handle those, and when you are going to handle it, we have to fix it, or we have to carry it some sort of conditions. So that conditions are related to the containerization. So maybe in any factory or a plant, it is inconvenient to handle the bulk loads we can say, or either in addition, if highly inconvenient and uneconomical to treat, we can say, a small size of components or products as a unit load. So different size of, we can say, this example, different containers with different color codes are there. There is again some more significance of these colors, but we'll try to understand this later on in our session. But these are the shapes of containers we can say. So different sizes and shapes are there for the container, which are used for handling the different bulk loads of maybe small size or maybe of unit sizes. So by definition we can say it is nothing but the process of converting the bulk loads or usually small loads into a unit load by using the containers. So containerization exam point of view, if asked, we can say that the process of converting the bulk loads or small loads into a unit load using the container. A few of the considerations are there in all these types of containers. So we have to limit the number of containers for the sizes and shapes we can say, or either the design container size shape based on the type of load we either, or either the size of the container taking into account the space available in the material handling equipment we can say, or either I said earlier, that is color codes are there. So most probably what type of usually containers are used for a containerization process. So basic three types we can try to understand. First one is simply the pallet, maybe a wooden pallet. Small wooden strips are arranged in a square pattern or maybe in related to rectangular pattern on which the products can be transferred. Second, we can say pallet type but in the form of a box. So maybe it may consist of a wooden structure, maybe of a metal structure. So pallet box is another type of container we can say, which will used for unit load transferation. Next type we can say the tote box, are either similar to the open type of box which are used for transporting the materials. So these are the basic three types of containers for transporting the unit loads. But always the flexibility is not there, that every type of product will be transferred in all these three types of containers. So sometimes we require different types of containers, or either we can see this on this slide, some sort of mesh type of structure containers are there. We call it as wire mesh containers. So wire mesh and solid mesh containers have some sort of difference. So wire mesh containers are usually preferred over wooden or plastic containers for the sake of cleanliness. So maybe if a liquid product is there, or sometimes the components are related with the transferring the fire effective products, so that time wire mesh containers are usually preferred. So in many applications we can say wire mesh containers are preferred over why. There may be few of the reasons. We can say self cleaning type of containers, because any type of liquid material, if it is fallen on this type of containers, usually it will throw out. So it will be the self cleaning type, or either when different parts are dropped into this container, we say in this type of container, so there will be less noise as compared to the solid containers. we can say either weight of the container will reduced, or either washing of these containers and removing of the component from all these type of containers will be easy. So or either cleaning, when if obviously if cleaning we follow, then drying is very much simple in these cases. So these are all different types of containers which will be usually used for containerization process. So in material handling, containers are of very much importance. So I think we have just a basic idea related to the containers. So coming to the other principles related to material handling. So before moving for actual design, so there are few basic principles which are to be selected, or we can say understood, for material handling equipments. So these are the stepwise principles. We can say first one, direction of load, length of load, type and properties of the load, or either characteristics of production process or local condition and initial and operating condition. So when we consider first one as suppose type of direction of load, so in which direction we have to transfer the load. So based on that we have to select the equipment, material handling equipment. So if suppose we consider we have to transfer the load from this place to downward, or either from bottom place to top one, that is we can say vertical movement of the load is to be followed. So that time different hoist or cranes we can say, or either different elevators are used. So direction of load depends and has a very importance, or we can say significance. Or suppose if you have to move the load in horizontal position, so that time different types of conveyor systems will be used. So different material handling equipments will be required. So based on the direction we have to select the equipment. So principle of selection depend on first factor, that is direction of the load. Second one we can say that length of the load. So length of the load is again much importance, because for how much distance we have to transfer the load, either it is too small or either it is too long. So based on that type of hoisting equipment depends. So for long distance usually either powered trucks or we can say conveyors are used, or related to small transportation we can say small hoist or elevators we can consider. So length of the, or we can say instead of length we can say distance of the load to be transferred. Next we have type and properties of the load. So what type of material we are going to handle, or what property of the load it is. So either the hoisting machines are suitable for unit load, or either we can say that conveyors are to be used which are suitable for bulk loads. Again related to unit load if we consider, so what is the weight of that, or either so these are all the factors or properties we can say, that is bearing surface, or either we can say suspension or brittleness or hardness, or maybe related to some components we have to transfer related to high temperature or too low temperature. So based on that we have to first identify the type and properties of the load. The topic is somewhat theoretical, but we have to clearly understand all the basic things related to that. Next one we have characteristics of production process. So what are the production steps we have to follow? Based on that either we have a local condition. So in characteristics we can say that whether the assembly lines or paint shop is there, or either forging and welding operations are there. Based on that equipments are to be selected. And if local condition come into picture, so whether what is the size and shape, what is the area, or either we can say the safety requirements, or either climatic conditions also play a vital role over there. Then comes the initial and operating cost. So obviously cost factor is very much important. So if you have to transfer small load and we are using a huge type of hoisting equipment, so it will not be of much more use. So the initial and operation cost are very much important parameter in selecting the material handling equipment. So for any given specific applications we can say. So these are the few principles, you can say 7 to 8 principles which are to be understood for material handling systems. So next, a few of the objectives we have to discuss related to material handling. When we understood all the principles related to that, then we have few objectives. So why we are going to do the material handling system? That is, first one, we have accuracy in transportation. So how much accurately we are transferring. So material handling system should transfer the load to the destination with the fair or either higher degree of positional accuracy, because position come into picture. So positional accuracy. Next we have precision, that is the material handling system should pick up the loads from their position within the shortest time. The time required should not be maximum, and maybe with or without human intervention, we can say. Then we have transporting the schedule time. So what is the schedule time? That is transporting the loads within the schedule time or not. That is material should move the load to their destination within the specific time. Then we have what type of quantity we have to transfer. So based on that, so how much is the quantity, the rate of supply of the material, we can say, if we are going to use the conveyor system. So that time the required quantity and rate. Then the product which is manufactured is to be transported without the damage, so there should not be harm to that, or either we can say minimum manpower. So automation when we follow, so minimum manpower can be used. Then we have low cost. So transportation cost should be minimum, either because it will add to the actual cost of the product. So the material handling system usually should not be maximum, but if it is there, so it should be minimum. And with that, maintenance and operational safety should be there for both. So standardization is to be followed for maintenance, and obviously the worker or human safety should be followed over. So these are all the related objectives, we can say, which are to be followed. So coming to the type of equipments which are to be used for material handling. So usually there are basic three types. First one we can say hoisting equipment, second one we have surface and overhead equipment, and third one we can say the conveyor system, most probably used for longer distance transportation. So hoisting equipments, in that we have three types usually. Hoisting machines, we can say, for vertical transportation, or either elevators are there, or either we can say cranes. So these are the three basic equipments. So related to that, I will show you some pictures or video photographs of the machines or equipments. Then we have surface and overhead equipments. So trackless trucks, we can say, or either narrow gauge car, we can say. Within the industry we can use these two types of equipments for transporting the loads, or usually most probably large scale industry, we can go with the conveyors if a small homogeneous material is to be transferred. So that time we can use the conveyors. So that is in that we have two types. First one is non-powered and powered type. In non-powered, we can say it requires the human intervention. So human intervention in the sense a human is required to operate all these type of equipments. So suppose two-wheel hand truck is there for transporting the load, with it consists of small two wheels, and this we can say the handle for operation. Or either if we use a powered vehicle, or either human hand for transporting this, so a four-wheel dolly, we can say. Or either we have hand operated lift, that is it is a powered lift, but it is usually hand operated. So this pallet is to be attached for this forks, in which, and it can be lifted with a small height. So a pneumatic system is included over there. So pull lever is there, and this fork enters into this pallet, and then we can transport this. So these are all non-powered industrial material handling equipments, we can say, or industrial trucks. Then we have power trucks, similar to earlier what we have seen over here. So if it is powered, that is a driving unit we required, so only the automated type, or either we can say steering control type of system is to be provided over there. So only the blue type of section, if you observe over here, it relates to the driving unit. So this driving unit will be the powered operation, so no need of human being over there to transfer this load. Next we have the forklift truck. So human will be just sitting on this truck and will be transporting the heavy loads. So powered type of equipments we can say are most probably used for transporting the high or huge loads or huge type of products. So it consists of the forks, the fork carriage, or either the overhead carriage on which it is maybe related to the safety of the operator. So long and huge boxes or containers can be transferred using this. So usually again the pallets are contained in these forks. Then we have a towing tractor. So towing tractor is somewhat similar to the non-powered type, that is a dolly, which we have seen in the earlier slide. So simply we are going to connect a towing tractor to that. So since powered come into picture, we can say it is a towing tractor. So component manufactured will be placed on the trailer and we can say we can move this. It is similar to somewhat tractor which are operated in by the farmers. So these are all about the equipments. Now we have different conveyor systems. So what are usually the conveyor systems? So conveyors are most probably used when material must be moved in a relatively large quantity. So continuously if production is there and a large quantity of products are to be transported, so that time we are going to use the conveyors. Again specifically between the two specific locations or over a fixed path. So conveyors are again classified into two categories. First one is the powered conveyors and second one we have the non-powered conveyors. So power type of conveyors, we can say the power mechanism is contained in a fixed path, maybe using the belts or either rotating rolls or either we can say other devices which are used for propelling, that is the trailer and tractor, one example which you have seen in the earlier slide. So to propel the loads along a given specific path, so these are the automated material transfer systems, powered type of conveyor systems. Then we can say that non-powered type is our second category. So it is most probably used again for moving either manually or by using the human workers who push the loads along the fixed path. So the equipment which we have seen, the non-powered equipments, come under the category of non-powered conveyor type of systems, or either most probably the belt drives which are human powered. So this come under the category of this conveyor system. Now based on the shape and size or the product, we can classify types of conveyors. First one we can say that roller type. So a variety of conveyor equipments we can say are available commercially, but out of that few major photographs and classifications we'll try to understand. First one is the roller conveyor. This type of conveyors most probably are used in the food industries. So this consists of a pathway of a series tubes, or either we can say these are the tubes. We can observe this photograph, or either over here these are the tubes, rolling tubes, and which are continuously rotating along its own axis. And due to that, what happens if the containers or we can say products which is placed over there, either a pallet, so it will continuously move and will move toward its destination. So a driving unit is shown over here, we can say this, and all the rollers are connected with the help of maybe either a chain drive. So one driving unit is there over here, another will continue to move. So this type of roller conveyors has a number of variety of applications, may be related to manufacturing, assembly and packaging. Another type we have belt type. Simply when unit rollers are used and that are not simply powered at all the centers, but we attach one belt above that, then it consists of the belt type of conveyor. It consists of continuous loop, that is one forward loop which usually for application purpose, and other is we can say return loop. But these two loops are supported with the either sliders or small rollers we can say, or either we can add a few type of idlers again. And out of that, two rolls are used, which out of that one we can say this cycler related to driving unit, and this we can call it as a driven unit. So material may fall on this conveyor and will travel to its destination. So this is related to the belt conveyor. Then another type we can say that chain and screw type. So chain type of conveyors consist of the chains and sprocket mechanism. For that different cleaning systems are to be used and discharge systems will be again used. Similar to this, it is working will be similar to the belt conveyors. Simply instead of belts we'll be using the chain drives. It will be used maybe most probably in the automobile industries. Next we have a screw type of conveyors. Screw type of conveyors consist of some screwing mechanism, maybe related to worm, which have some sort of helix angle, so that it will rotate in a trough or a tube and it will transport the material. So similarly screw conveyors has much more application related to the food industries. So consisting or understanding all the types of conveyors equipments, we can say a total system will consist of different elements. So out of that, one example is shown over here, that is one system is shown and few numbering are to be provided. Suppose from this we can say this is a hooper, that is 30 number. Hooper will be transporting the homogeneous material, and then on this conveyor system it will move towards its destination. So how it will move, based on that a rotating or driving unit will require. So driving unit is this head one, so head pulley is our driving unit, and this will be a tail pulley which will just rotate. But when this moving system is provided, at that time we can say that a belt will be in contact with the component. So this component will provide some sort of particles to that belt, so that we have to clean. So for that we require a belt cleaner over here, and with that some sort of tensioning is to be provided for this belt, because this material will have its own weight and it is to be placed on this. So supporting idlers are there, we can say snub pulleys are there, bend pulleys we required for providing the tension, and some sort of counterweights or dead weights are to be attached over. So this all elements together consist of a conveyor system. Now most probably our target is to design this type of conveyor or a belt system. So inclined type, or we can say blanketed type of conveyor system also required whenever material is to be transferred from bottom to top. So that time to avoid the slippage, so we are going to add a blanketed type of another conveyor system over there. Next consists of a woven type, which consists of a net or a meshing type of conveyor system. Instead of belt we'll be using either a stainless steel mesh or either a mild steel mesh. Actual photograph you can observe over here. Most probably use of this is woven or either quenching baths. So maybe in heat treatment industries or heating industries when you have to follow, so such type of conveyor systems are used. Then we have trough type, either hollow type or flat type we can follow. So if actual photograph you can see idlers are used. If we increase the number of idlers we can get more space in this. So these factors B, H and capital B, psi, beta, will discuss this later. But time being we can just observe the photographs and we'll try to understand what exactly the trough type of belt conveyor look like. Next, if we move inside this belt drive or conveyor systems, so there are two basic types. First one we can say the fabric type, and second one we can say is related with the steel cords. So fabric type usually consists or maybe made from a rubber, and inside that we are going to add the fabric layers. So simply that conveyor belt is not made from a homogeneous single material, but it's made from different types of layers. So first layer we can say is made of rubber, or either second layer may be made of a fabric, or maybe made from a resin or epoxy. So to provide the longer life and tension and strength to this belt, we are going to apply different types of layers. Or sometimes if high weighted components are to be transferred, so that time we add some steel cords over there, maybe horizontally and vertically, to make a mesh over there. So and then we cover both this cords with the help of a small fabric or a rubber. So these are the two basic types of conveyors which are to be understood in this video again. Then come into picture related to idlers. Though when we have understood the conveyor systems, so that time we are side by side we should understand the idlers which are used for supporting the systems. So most basically we can say a roller type of idlers with either ball bearings are used, the rollers which we have seen in the earlier slide. So roller bearings may be there, or either ball bearings will be used. And sometimes the material if placed on the conveyor system, so impacts may be there. So this different impacts are to be hold up or cover up, so with the help of impact idlers. Then we have spring type of materials, or either the different disc type. And important is to provide the tension. So belt take up devices are there. So after a number of uses or rotations of this belt, maybe for 8 hours, 10 hours, or either maybe for 2 to 3 days, we have to add some sort of tensioning in that belt. So two type of belt take up devices we can say, either horizontally or either vertically, are to be used. So for that, most probably a good example is the counterweight. One counterweight over here in case of horizontal we can say, or either vertically a counterweight is to be attached. So for that we require two pulleys, that is bending pulleys, or we can say bend pulleys, and the take up pulleys. So when we add the weight, counterweight we'll say, so obviously the tension in the all sides of belts will be increased and the materials will be transferred. So these are the basic systems of belt take up. One is beyond below this, or either to beside of the conveyor system we use the horizontal type of gravity system. So a wheel or tail trolley type of, which is attached with a guide way and a pulley. Or either we use a range type, that is in a range type we can say, or winch type, powered motorized mechanism is used to provide the tension. Or either a screw type of conveyor system. So if we want to increase the tension in the belt system gradually, so that time most probably screw type of belt take up devices are followed. So these are the basic four types of belt take up systems, and most probably it is required because it is by number of handlings the belt become loosened. Then comes into picture the method of discharge of the felt belt types. So the discharge of the component from the hooper may be to the single side or maybe from the both side. So both side discharge may be there, or either the tripper and plow type. Tripper and plow type may be related to the food industries. So when inspection is to be followed besides side by side, so that time tripper type, so heavy weighted component. So suppose this example you can say a component is placed over here, material is placed over here, and it is traveling from this to this tip, and suddenly there is a drop in this. So the material which is high weighted will settle down over here and will be removed through this tripper, and either all remaining material which is required when we will move towards the destination. So this is the tripper type of discharge. Or either small size of plows are used, which may be related with the help of sensors, or either maybe directly, which will remove the coarse and material, and finer material will move on to its destination. So I think this much will be sufficient for today's session. The related design, the capacity will be discussing in our upcoming sessions. So in today's session, at least we have got an overview related to the belt conveyor systems or material handling systems. So that's all for today's session. Thank you. Thank you once again for attending this session.